Hi everyone, this is Mrs. GA, and today we're going to talk about conditions of rectangles, rhombuses, and squares. So essentially we're going to start talking about ways to prove that a parallelogram can be classified as a rectangle or rhombus or a square. And please note that we are starting with the fact that they are already parallelograms. So here's two different ways to prove that a parallelogram is a rectangle. So if one angle of a parallelogram is a right angle, meaning 90 degrees, then we can conclude that the parallelogram can be considered a rectangle. The reason for this is that if one is a right angle, since the lines are parallel, then we know that these are going to be supplementary, so this must also be 90, this must be 90, and so must this. So therefore they would all become 90 degrees. The second way that we can prove that a parallelogram is a rectangle is if the diagonals of a parallelogram are congruent, then the parallelogram must be a rectangle. So here, if AC is congruent to BD, then it is considered a rectangle. Okay, so now let's talk about some different ways to prove that a parallelogram is a rhombus. So if one pair of consecutive, which means that they're next to each other, if one pair of consecutive sides of a parallelogram are congruent, then we know that the parallelogram is a rhombus. So you can see here we have a parallelogram, and it shows in the picture that EH is congruent to EF. So since these two sides are consecutive, they're next to each other and they share a common point, we know that this parallelogram is a rhombus. The second way we can prove that something is a rhombus is if the diagonals of a parallelogram are perpendicular, meaning that they make 90-degree angles, and remember the little symbol for perpendicular looks like this, then the parallelogram is a rhombus. So here you can see that where these two diagonals intersect, we see a 90-degree angle, which means that the diagonals are perpendicular. Last, if one diagonal of a parallelogram bisects, which means cuts into two congruent parts, if it bisects a pair of opposite angles, then the parallelogram is a rhombus. So you can see this diagonal bisects this angle because these two are congruent, and also bisects this angle because these two are congruent. So it only takes one of them, one diagonal bisecting, to prove that it is a rhombus. Okay, and to prove that a parallelogram is a square, of course, we could say if all four sides are congruent and all four angles are congruent, then the parallelogram is a square. It's the definition of a square. And then we can also say if the diagonals of a parallelogram are both perpendicular and congruent, then the parallelogram is a square. So you can see that this really comes from the theorem for a rhombus, and this comes from the theorem for a rectangle, because remember, a square can be classified as a type of rhombus or as a type of rectangle. It's a more specific type of quadrilateral. So moving down here, for example 1, we're going to determine whether each conclusion is valid. And if it's not valid, we're going to tell what additional information is needed to make it valid. So here we are given that AC and BD bisect each other. We are also told that AC is congruent to BD. So they bisect each other and they're congruent to each other, which means all four parts are congruent. So we are trying to decide if this conclusion is valid, that ABCD is a square. So remember, when we say that the two diagonals bisect each other, this is a property of a parallelogram. So it does prove that the quadrilateral is a parallelogram. When it says that AC, right here, is congruent to BD, when it says that these two are congruent, that gives us the property of a rectangle. However, you can see that we don't quite have enough information to conclude that it's a square, because to conclude that it's a square, the diagonals must be perpendicular and congruent. So the information that's missing is that AC and BD are perpendicular. This fact is missing. So if we knew this fact, then we can conclude that it was a square. So let's look at part B. For part B, here we are given that AC is perpendicular to BD. So we're told this, I'll write it in blue. And we are also told that AB is congruent to BC. So this is actually enough information to in fact conclude that ABCD is a rhombus. So remember, with a rhombus, one of the theorems was if one pair of consecutive sides are congruent, then it must be a rhombus. So we know that AB and BC are consecutive sides and they're congruent, so that makes it a rhombus. We also know that if the diagonals are perpendicular, then it must be a rhombus. So we actually have two facts that confirm that this figure is a rhombus. So I can write valid. Okay, so for this last example, we're going to use the information to determine whether or not the quadrilateral is a rectangle. And then we're going to explain how we know. So in this one, this first one, they say EF and GH are congruent, and then FG and EH are congruent. So these two facts tell us that the opposite sides are congruent, which tells us that it is a parallelogram. So that's a good place to start. And next thing they tell us is that FH and EG are congruent. So this fact tells us that the diagonals are congruent, and that is one of the theorems that we can use to prove that a parallelogram is in fact a rectangle. So again, this first fact told us that it's a parallelogram. This second fact told us that it is a diagonal. So we can say, yes, this is a rectangle. Okay, so for number 4, they tell us that the measure of angle FEG is 45 degrees, and the measure of angle GEH is 50 degrees. So if we know that this is 45 degrees and this is 50 degrees, we know that angle FEH is going to be the sum of those two smaller angles. So it's 45 plus 50, so angle FEH in this case is 95 degrees. So for a rectangle, we know that all of the angles must be right angles, and we need to have 4 of them. So since this is not a right angle, then we can conclude that this is not a rectangle. So if this were the information that we're given, we would say that this is not a rectangle because, again, angle FEH is not a right angle. Okay, that is all for today's video. Thank you so much for watching.